The James Webb Space Telescope, one of the most sophisticated eyes in space, recently captured something extraordinary. This discovery on Mercury, right under our noses near the Sun, has forced NASA to act fast. What is it about Mercury, the smallest planet in our solar system, that has prompted such a reaction? What was once thought to be just a rocky, barren world scorched by the sun has now been revealed to be much more than that. With new findings challenging everything we thought we knew, Mercury may be small, but it's far from ordinary. This tiny planet, closest to the sun, is full of surprises that continue to puzzle scientists. One of these surprising discoveries is that diamonds are thought to be scattered across Mercury's fiery surface. How can such valuable and delicate formations exist in one of the hottest places in the solar system? As we get to know Mercury better, we're making some pretty amazing discoveries that are changing what we thought we knew about how planets are formed and evolve. There's more to Mercury than meets the eye. Beneath its rocky exterior lies an enormous dense core, much larger than scientists initially predicted. This core is the key to many of Mercury's anomalies, but it also raises some new, more perplexing questions. How did Mercury, a planet that's smaller than the Moon, end up with such a massive core? Could it be the result of a major event in the planet's early history, or is there another explanation? One idea is that Mercury used to be a lot bigger and lost its outer layers in a violent crash, leaving behind the dense core we can see today. This is just one of many scenarios that we're now looking into. Our journey of discovery on Mercury started decades ago with NASA's Mariner 10 spacecraft, the first to visit the planet. Mariner 10 gave us our first close-up look at Mercury. It showed us a cratered moon-like surface and gave us the first clues that Mercury was more than just a dead rock in space. Mariner 10 also found that Mercury has a magnetic field, which was a surprise because it's a small planet. It also suggested there might be a much larger core than previously thought, but we wouldn't know the full extent of this for another 30 years. In 2004, NASA launched the Messenger mission, which was designed to orbit Mercury and provide detailed long-term observations. Messenger's data transformed our understanding of the planet. The spacecraft took over 200,000 images of Mercury's surface, uncovering areas we'd never seen before and giving scientists an incredible view of the planet's landscape. And there were more discoveries than just photographs. Messenger's instruments also picked up unexpectedly high levels of elements like calcium and magnesium, particularly on the darker side of the planet. This led to new questions about how and why these elements are present in such abundance on Mercury. Another of Messenger's key discoveries was that Mercury's magnetic field is even more unusual than we first thought. While our planet's magnetic field is pretty uniform, Mercury's is much stronger in the northern hemisphere than the southern one. This irregularity suggests that Mercury's internal structure and the processes that generate its magnetic field are highly unique, setting it apart from other planets in the solar system. On Earth, the magnetic field is generated by the movement of molten iron in the core, but Mercury's core behaves differently due to its size and composition. These differences indicate that there is an internal dynamism on Mercury that scientists are still trying to fully understand. The environment on Mercury is pretty extreme to say the least. During the day, temperatures on the surface can reach 800 degrees Fahrenheit, which is hot enough to melt lead. But at night, the temperature drops to almost minus 300 degrees Fahrenheit. This huge temperature change is down to Mercury's thin atmosphere, or more accurately, its exosphere, a thin layer of particles that can't retain heat. Despite these harsh conditions, there have been signs of volcanic activity on Mercury, which challenges the idea that the planet was geologically inactive. In 2012, Messenger found evidence that explosive eruptions had happened on Mercury in the past. And in 2020, new research suggested that the volcanic activity might have been more recent than we thought. The most surprising find was at Mercury's poles. Even though it's close to the sun, there's water ice in areas near Mercury's north and south poles, in craters that are always in shadow. It's hard to imagine that a planet so close to the sun could have ice. But there it is, preserved in the eternal darkness of these polar craters. The discovery of water on Mercury has got people wondering about the planet's history. It makes you wonder if Mercury might have had more favorable conditions for life in the past. Could these icy pockets be home to life forms similar to extremophiles on Earth? The upcoming BepiColombo mission, a joint project between the European Space Agency and the Japan Aerospace Exploration Agency, is expected to provide more insights into Mercury's mysteries when it reaches the planet in 2025. BepiColombo will collect even more detailed data about the surface of Mercury and its geological history. As we look forward to BepiColombo's findings, we can't help but wonder what new secrets will emerge from this enigmatic world. Even though it's a small planet, Mercury has a complex interior, a magnetic field, and a history of volcanic activity, which suggests it's been far more dynamic than we ever imagined. One of the most unusual things about Mercury is how it has a day-night cycle. Mercury has a longer day than a year on Earth. It takes 176 Earth days for Mercury to complete one rotation, compared to just 88 Earth days to orbit the Sun. This means that if you were standing on Mercury, you'd see the sunrise, move across the sky, stop, move backwards, and then continue forward again. This unusual behavior is down to Mercury having a unique spin-orbit resonance, which means it rotates 3 times for every 2 orbits around the Sun. The extreme heat on the side of Mercury facing the Sun and the freezing cold on the side facing away create some of the most dramatic temperature variations in the solar system. Mercury's lack of a substantial atmosphere also has a significant impact on the planet's surface. Without an atmosphere to protect it from solar radiation and impacts, Mercury is constantly bombarded by solar wind and space debris. These impacts create a thin exosphere, mostly made up of oxygen, sodium, hydrogen, and other elements that are constantly escaping into space. New data from MESSENGER in 2020 showed that there's more water vapor in Mercury's exosphere than we thought. This has led scientists to wonder what might be responsible for releasing this water vapor into the exosphere. Another thing that makes Mercury special is its magnetic field. It's not as strong as Earth's, but it's still pretty important for protecting the planet from the solar wind. Scientists are still trying to figure out how Mercury's magnetic field is generated given the planet's small size and slow rotation. One theory suggests that the movement of liquid metal in Mercury's core, influenced by its unusual spin-orbit resonance, is responsible for generating its magnetic field. This has prompted researchers to rethink how magnetic fields form, not just on Mercury, but on other planets too. Mercury's chaotic landscape adds to the mystery. In particular, there's an area near the southern pole, known as the chaotic terrain, which is marked by hills, valleys, and ridges that seem to have been formed by massive quakes. These were likely caused by the Sun's gravitational pull as Mercury's orbit changed over time. These quakes may have played a big part in shaping Mercury's surface, but they also point to deeper internal processes that scientists are only just starting to understand. One of the main ideas is that these quakes are connected to Mercury cooling and shrinking over billions of years. As the planet's core solidified and its crust gave way to the pressure, this led to these quakes. Another thing that makes Mercury special is its magnetic field. It's not as strong as Earth's, but it's still pretty important for protecting the planet from the solar wind. Scientists are still trying to figure out how Mercury's magnetic field is generated, given the planet's small size and slow rotation. One theory suggests that the movement of liquid metal in Mercury's core, influenced by its unusual spin-orbit resonance, is responsible for generating its magnetic field. This has prompted researchers to rethink how magnetic fields form, not just on Mercury, but on other planets too. Mercury's chaotic landscape adds to the mystery. In particular, there's an area near the southern pole, known as the chaotic terrain, which is marked by hills, valleys, and ridges that seem to have been formed by massive quakes. These were likely caused by the Sun's gravitational pull as Mercury's orbit changed over time. These quakes may have played a big part in shaping Mercury's surface, but they also point to deeper internal processes that scientists are only just starting to understand. One of the main ideas is that these quakes are connected to Mercury cooling and shrinking over billions of years. As the planet's core solidified and its crust gave way to the pressure, this led to these quakes. Recent studies have given us new insights into how Mercury is structured internally. It seems that Mercury has a liquid outer core and a solid inner core, just like Earth. However, Mercury's inner core is much larger in proportion, making up about half of the planet's total volume. This could explain some of Mercury's unusual magnetic properties and geological activity. Mercury's surface shows evidence of contraction, unlike Earth, where tectonic plates are constantly shifting and reshaping the surface. This is indicated by large thrust faults, which show that the planet has shrunk as it cooled. These faults are some of the most obvious signs of the geological activity that is still going on Mercury. Despite the intense heat, scientists have found elements on Mercury's surface that they never expected to find. In 2020, researchers found volatile elements like sulfur, potassium, and sodium, which usually vaporize at high temperatures. This has led to the idea that these elements were brought to Mercury by comets or asteroids a long time after the planet was formed. The discovery of these materials challenges our understanding of how planets close to the Sun evolve and retain volatile compounds. One of the most interesting questions that has come up as a result of the recent discoveries about Mercury is whether the planet could ever have supported life. While Mercury's surface is currently pretty unwelcoming, with temperatures that swing from one extreme to another and no substantial atmosphere, the discovery of water ice and organic materials in the planet's polar regions suggests that there may have been a time when conditions on Mercury were more favorable. Scientists are now looking into the idea that Mercury's icy craters could be home to life forms similar to those found in Earth's harshest environments. These extremophiles, which can survive in extreme cold and without sunlight, provide a model for what life might look like on other planets. Knowing more about Mercury's geological history and internal structure also helps us understand other rocky planets, including Earth. Studying Mercury's core, mantle, and crust helps scientists understand how the planet was formed and how this affects the other terrestrial planets. For instance, the core of Mercury makes up 85% of the planet's total volume, which is far more than the core of Earth or Venus. This has led researchers to think that the way Mercury was formed was different to how the other inner planets were formed. If Mercury was once a larger planet, as some scientists believe, then it may have lost a lot of its outer layers in a massive collision early in its history. This would explain why its core is so much bigger than its mantle and crust. Mercury's surface is also a great record of the solar system's history. The planet's craters, some of the oldest in the solar system, give us clues about how planets were formed and how our neighborhood in space was shaped. The discovery of water ice, organic materials, and volatile elements on Mercury not only challenges our understanding of the planet, but also opens up new avenues for exploration. As we get ready for the BepiColombo mission, scientists are excited to see what new data it will bring back about this mysterious world. Mercury is a fascinating subject of study thanks to its extreme environment, complex internal structure, and history of dramatic geological changes. It offers a window into the mysteries of our solar system.